A researcher wants to assess the damage to memory that's caused by excessive alcohol consumption. A sample of 10 patients with chronic alcoholism is obtained from the hospital treatment ward, and a control group of 10 hospital maintenance staffs is also pulled for the study. So we have drinkers and non-drinkers. Okay, so what the researcher again is trying to say, okay, what's the effect of this chronic alcoholism? Does that have an effect on memory at all? Right? So effect is going to be more two-tailed test. Let's run it as an alpha 0.05. So let's go alpha 0.05 two-tailed test. Okay. Now, one of the first things we need to do is look at our data. So let me give you the data. Okay, so I'm going to say A for the chronic alcoholics and then NA for the non-alcoholics or non-drinkers. Okay, so they gave them this memory test, and the average score for the alcoholics were 43, with a sum of squares of 400. Now the non-alcoholics, or the people that were pulled from just the hospital maintenance staff, had a average score of 57, with a sum of squares of 410. Okay. So the first thing we need to do is we need to find if this meets our homogeneity of variance assumption, because if it doesn't, we cannot proceed. Okay, so let's find our F max first. Okay, so we go over here to our critical values of F max, or our F crit table. Right? So we'll call it either F max or F crit. What this is like saying the ceiling. This is the most amount of variance discrepancy, right, difference between the variances between the two samples that will be allowed to proceed. And if it goes past this F crit or this F max ceiling, this limit, we cannot proceed. Okay, so again, we go degrees of freedom is n-1. So in our case, we have, for sample size, we have 10, so we have 9 for our degrees of freedom, right? So we're going to look in this range right here, and we're only dealing with independent t-testing, right? So t-testing is only going to be when we have 2 samples. The other one is more for ANOVA, right? So with this one, it's just 2 groups, right? We have the alcoholics and the non-alcoholics. So we have 2 groups, alpha set at 0.05. Let's see here. So we have degrees of freedom 9. So our F max is 4.03. So when we run our statistical analysis to find our F obtained, and again, our F obtained is variance divided by variance. Variance, the larger variance between these 2 groups, divided by variance, the smaller variance between the 2 groups. Okay, we just can't blow past this 4.03 maximum critical value of F. Okay, so if you remember, variance is the equation of sum of squares divided by n-1. So let's run that for both of the groups. All right, so we'll go. We'll start with the alcoholics first. So we have 400 right, divided by n-1 is 9. Right, so we get 45.55 repeating. And if we do that, oh, nope, sorry, that was the other one. We get 44.44 repeating. And if we do that again with our non-alcoholics or control group, that's when we get the 45.55 repeating. Sorry. So 410 divided by 9 is 45.55. 400 divided by 9 is 44.44. Okay, so this one is the smaller one, and this one is the larger one. Okay, so larger goes on top, so 45.55 divided by 44.44 gives us an F obtained of 1.0249. Don't pull it out too far, but that's pretty close. Okay, so 1.025, we'll say. Okay, so our F max was 4.03. We can't go past that number, and we didn't. Our number was 1.025. So we have met that homogeneity of variance assumption, and we can proceed. Okay, moving on to finding our test statistic, or our T obtained. Right, because now we have verified that we have met the homogeneity of variance, so we can proceed. Okay, so let's go back and let's find our critical regions. All right, so we do know it's a two-tailed test. So we're either hoping that the memory for the alcoholics fall into this top group or in this bottom group. Either one is the critical region. Either one will give us the ability to reject the null hypothesis, but anything in here, right, this will be like the fail to reject. So we don't want to get in there if we're trying to prove this actually has an effect on memory. Okay, so our degrees of freedom, right, is 18, because degrees of freedom for independent t-testing is n for the first group plus n for the second group minus 2, or in this case 10 plus 10 minus 2 gives us 18. Okay, so we have two groups, so get out your t-table and you will see that the t crit, or the critical value of t as set by that alpha level 0.05 two-tailed test, right, is plus or minus, right, so we'll start over here, minus 2.101 or positive 2.101. So either one, if our t obtained falls into one of those two critical regions, we can reject the null hypothesis. So the first thing we need to do is find our pooled variance. Okay, and pooled variance is the sum of squares for the first group plus the sum of squares for the second group divided by the degrees of freedom for the first group plus the degrees of freedom for that second group. Okay, or in our case, right, we have 400, right, was our sum of squares for our alcoholics, and 410 for the non-alcoholics, divided by 9 plus 9, or 810 divided by 18. So our pooled variance is 45. Okay. Once we have pooled variance, we can use this next formula here, right? And this is the estimated standard deviation of the mean differences. So pooled variance divided by the sample size for the first group, and we have equal sample sizes and equal pool variance is equal together, so these will be quite similar, right? So the square root of 45 divided by 10, because now it's not degrees of freedom, right? It's sample size, or 4.5 plus 4.5, the square root of that. And that gives us 3. Okay. Now we can put that into our t obtained formula, right? Now this is like the long one, right? Most people don't use the full, it's supposed to be mu, sorry. Let me just start that all over again. That's really sloppy. I apologize. Okay, so it's supposed to go mu1 minus mu2, okay, all over this large one that we had just found, right? Okay, so like I said, this one right here is always 0, so you won't write it out, to just kind of assume that that's 0, but this one is the needed one, right? These two means right here we definitely need to have. Okay, so we had mean from our first group, right, the alcoholics, was 43 minus 57 for the non-alcoholics, divided by, 3, right? Okay, and then, let's see here, so you have 43 minus 57 divided by 3, or negative 14 divided by 3, gives us a t obtained of negative 4.67, and we compare that to our t crit, right, 2.101, and so our t obtained is like way over here. Our t obtained is negative 4.67, so that's huge, right? And because it's huge, then we need to find the effect size, and we'll do estimated Cohen's d, or d hat, right? And the equation for estimated Cohen's d, mean 1 minus mean 2, divided by this square root of the pooled variance. In our case, 43 minus 57 divided by the square root of 45, okay, or 14 divided by 6.71, or our D hat is 2.09. That's huge. That's like extra large effect size. So again, the initial question was, a researcher wants to assess the damage to memory that's caused by excessive alcohol consumption. And they grab 10 adults from the hospital treatment ward for alcoholism and 10 non-drinking adults from the hospital maintenance staff. And each person in those groups are given a memory test. And the average scores, right? 43 for the alcoholics and 57 for the non-alcoholics. We showed that an alpha level, or having a confidence level of 95%, so alpha level 0.05. Two-tail, we rejected that null hypothesis, so we're in essence saying that yes, chronic alcoholism does have a really strong negative effect on memory, or that it really impedes your memory as you continue to age and drink.